Today we're going to talk about the sum of a geometric sequence, which is called a series. So we have the geometric sequence 2, 6, 18, and 54. First thing we want to do is find a common ratio, and this will give us our R value, which we need for the formula for a geometric sequence or series. So from 2 to 6, 6 to 18, 18 to 54, all of those I hope you can see are by multiplying the previous term by 3 to get that next term. So that's easy enough. Our R is 3. Now to find the 10th term, we've done that. You did that with arithmetic sequences, and you also just did it with the geometric sequences. You know that to find the 10th term, you need the first term, which is 2, times the ratio, which is 3, to the n minus 1. So 10 minus 1, which is the 9th term, or to the 9th power. So in doing that, we get 2 times 3 to the 9th power. Go ahead and figure that out. You should have gotten 19,683. And 2 times 19,683 is 39,366. So that would be the 10th term. Well, now we want to find the sum of the first 10 terms. We could go through and we could continue this pattern out. And if you do that, we get 2, 6, 18, 54. Multiplying that by 3, we would get 162. Multiplying that by 3, we would get 486. Multiply that by 3, 1,458. Multiply that by 3, 4,374. 13,122. And then the 10th term would be 39,366. So you could go through, you could write it all out, and then add them all up. And if you were to add all of those up, you would get 59,048. But you're not always going to want to do that. You're not going to want to take the time to list them all out and then turn around and add them all up. So we use the formula, the sum of a certain number of terms of a geometric sequence is the first term times 1 minus the ratio to the n power, all divided by 1 minus r. You will be given this formula on your test and also when you guys take the park. So it would be helpful if you would try to remember it. It's not that difficult once you keep writing it down. So we want to know the sum of the first 10 terms of that sequence. Well, a sub 1 is our first term. Our first term was 2 times the quantity of 1 minus the common ratio, which is 3. We want the 10th term, so it would be 3 to the 10th power, all divided by 1 minus 3. When you do this, you put this in your calculator, you do end up with 59,048. I'm going to run out of room here, which is why I'm not going to go through and do it individually. But 3 to the 10th power is 59,049, and 1 minus that would be a negative 59,048 times a positive 2 divided by a negative 2. You end up with a positive 59,048.